Hello, my name is Julia, and this is Space Daily News channel. NASA has approved the continuation of work on the FarView Lunar Radio Telescope project. It's proposed to build it on the backside of the Moon using lunar materials. The backside of the Moon is considered an attractive region to place a radio telescope, as it is protected from radio noise from the Earth and during the lunar night from radiation from the Sun. FarView is a low-frequency radio telescope consisting of 100,000 dipole antennas spread over an area of about 200 square kilometers. The observatory antennas are proposed to be fabricated directly on the Moon, using technologies developed by Lunar Resources company. To do this, it is first necessary to obtain metals and oxygen from the lunar regolith, and then from these materials can be produced most of the necessary elements of the observatory: dipole antennas, solar panels, and power lines. At this stage, potential sites for the observatory have already been identified. An initial list of equipment to be deployed to build the observatory has also been compiled. Initial physical parameters and requirements for the dipole antennas, power lines, and solar panels were determined. An initial observatory architecture and several system implementation models have been developed. In the coming years, the FarView observatory concept is planned to be developed through modeling and experimentation to address key questions regarding both the scientific performance and manufacturing processes required to build the FarView telescope on the backside of the Moon. In addition to FarView, NASA is also funding two other projects that also involve building a telescope on the Moon's surface: the Far-Side Radio Interferometer and the Lunar Crater Radio Telescope with field aperture. The Far-Side telescope is expected to consist of a central base station and 128 antenna nodes distributed over an area of 10 square kilometers. The interconnected antennas will be installed in series with a lunar rover. The base station will provide power, signal processing, and communications with Earth. Another NASA-funded project, the Lunar Crater Radio Telescope, is also interesting. This project proposes to deploy a 1 km diameter wire mesh using small duaxial lunar rovers in a 5 km diameter lunar crater on the backside of the Moon to form a spherical reflector. A suspended receiver will then be mounted over the center of the resulting telescope antenna. Such a 1 km diameter radio telescope could become the largest radio telescope with a field aperture in the solar system. It will make it possible to observe the early universe in 50 meters wavelength range, which has not yet been explored by humans. Space Daily News. Like, share, and subscribe.